All right, welcome to your next session at AI4. I hope you're having an awesome time so far. Our next session will be led by Subroto Mukherjee. He is the Head of Innovation and Emerging Technology Americas at GlaxoSmithKline. Please join me in welcoming him to our virtual stage.
Just to give you a welcome to the next in Enterprise AI 2020. This is Subroto Mukherjee. I'm head of innovation, digital innovation, emerging tech, consumer healthcare, GlaxoSmithKline. Uh, just to give you a quick introduction of the company, it was founded in 1873. The company's first pharmaceutical product was released in 1924 as vitamin D. You can see the billboards and the way it was being displayed during those days, which is like pretty interesting to see the way we have now our newer billboards and display ads. So a little bit more about my company, GlaxoSmithKline. It's a science-led global healthcare company with a special purpose to help people to do more, feel better, and live longer. We have three global businesses that research, develop, and manufacture innovative pharmaceutical medicines, vaccines, and consumer healthcare product. And I'm part of the consumer healthcare division, which is giving a lot of consumer uh, products. And if I'm going to share you the key ones, we are number one in pain relief with Advil, Thermacare, Voltaren Gel. We also are part of the minerals and supplements. Centrum is one of the key ones. Respiratory, we have Theraflu, Robitussin, and then in digestive health, we have Tums. And in oral care, it's pretty popular across the globe is Sensodyne, and in skincare. So also, we are giving back to the community. If you see, we are partnering with Smile Train, and Smile Train is a world-leading charity who offer free life-changing surgery and comprehensive cleft care to children in more than 85 countries. And over the next 5 years, we'll be providing Smile Train with valuable funding and support and expertise to help ensure more children are living with the cleft, can lead a more full and productive life. And we are also working together to transform lives. Just a brief background of what we're going to do today. We will discuss about the current enterprise adoption AI status, AI data and bottlenecks, enterprise AI infrastructure needs. So which is my core theme today, how we speak about enterprise needs from data pipelines to cloud. And I will talk in terms of looking at the GSK use cases, which are our things which we are doing in for our AI initiatives. A couple of key use cases would be seasonal prediction and how the data pipelines and machine learning models are built and deployed, and how our ML operations can be used to deploy the models. We also will go over a couple of additional use cases quickly on chatbots, eye tracking, and image classification, and obviously conclude with the bigger topic nowadays with ethical AI. If you look at the enterprise AI adoption, which is a survey was done by O'Reilly in 2019, the organizations, which is kind of at what stage they are in, if you look at it, computer, electronics, and technology is pretty high in that lane. They are 48% of evaluation stage and 36% in more mature practice. Financial services come later. And then I think from our group, we are part of the healthcare and life sciences company. We are at 29% and 59% of evaluation stage. Telecom comes later, and obviously public sector and government is still behind. They're catching up as you go in this in this part. What are the key enterprise AI challenges? If you look at it, I think pretty much everybody in this who are listening to this presentation are pretty much aware of this, right? We are having key factors are data, talent, and trust. And data is the foundation fuel for AI. Without data, none of your AI activities can go ahead in a better way. And then what are the key issues in data right now? If you look at it, we have data siloed across the organization, obviously for many reasons, for organizational reasons, political reasons, other things. Every organization has own set of data. They are for different purposes stored in a different manner. The next one is pretty obvious is lack of data. If you are going to run many deep learning and machine learning models, lack of data is going to be your key impediment. You cannot move ahead unless you have a solid set of data set to kind of move ahead. And then obviously we have more disorganized data. Data is pretty disorganized across the board. And then bad data, with a lot of noise and less signal in the data. So these are the key factors a lot of the organizations are facing, including us. We are trying to break the barriers. We are trying to break the silo of data. We are trying to get more and more data, acquire more and more data, and then try to organize the data sets around it and try to remove the bad apples out of that. If you look at the enterprise AI bottleneck, which is kind of holding back further for us, is obviously company culture comes as one of the factors for us. And if you look at the number from the survey just provided, again, one of the factors in O'Reilly, we have seen that is basically company culture does not recognize the need of AI. There's a 23% of that was being identified. A lot of the companies still grasping the facts, even though we are talking a lot of this. This is still not being recognized very clearly about that. Again, I mentioned the last slide about the lack of data quality issues is one of the key reason for the AI bottleneck. And then another one is pretty obvious in nowadays is the talent and skill of people to use the data, apply it, and then finding solution out of that. Then the difficulty is in identifying appropriate business use cases. We are still challenged to present the right business use case with the key factor nowadays, value being a very big factor. Um, Identifying the valid use cases is very big challenge nowadays. Technical infrastructure challenges kind of slowing down because a lot of things is cloud is becoming more and more easier, seamless. Transition to cloud is happening. So our technical infrastructure challenges kind of going down. Legal and compliance issues are becoming as also there. For example, when we had to launch chatbots, we need to make sure all our legal and compliance teams are there. We have, especially with pharmas and reporting and medical and consumer healthcare products, we need to make sure that adverse events are being captured. Typical of any of this is very part of any enterprise product we launch. We have to go through those cycles, get onboarding all the different teams as part of that. Next is enterprise AI challenges, trust. AI trust is one of the key ones where you want to make sure that the audit of the lineage of the models and associated training data, along with inputs and outputs of each AI recommendation, is very looked at very carefully. So the key factors of trust for the trust are, if you look at it right now, is fairness, which is the data scientist's aspirations to have a fair game of outcomes. Explainability. Now, a lot of the models, they need to really be able to explain why are they, where are they, especially with predictive models and seasonal models, which I would talk in a little while, soon. And then robustness, right? There was good news about a neural network model was hacked to prove that a cat was a toaster. So you need to make sure that you have a robust infrastructure and security infra in place so that you can make sure that the models are not attacked, they're being easily monitored, and they are being giving you the best results out of it. Value alignment is, again, many models. If you look at the scoring, the levels, which typically we are using the MAPE scoring in many of the models to see if they are within certain limit of MAPE scoring. Are you able to distinguish between a good and bad outcomes? And then outcomes should be aligned with the business value. Those are the key AI trust and challenges we are looking across the board, and we kind of make sure that everybody is aligned with those trust challenges. Now, in the enterprise AI, business priorities is becoming a bigger point for us, like which is I was mentioning just before, is how do you even determine the right business problem to solve with the current COVID situation, with a lot of financial challenges, the things we want to make sure we just don't want to run and start projects on AI projects just for the heck of starting the projects, right? There has to be a good amount of predefined business problem it is solving. The what is the priorities? Because since we start opening the floodgates of AI projects and other initiatives, we are want to make sure that if there are 10 of them in the pipeline, we can prioritize them and make sure we are picking up the right ones to solve for where at the moment, which gives you the immediate results. So typically the things we are using is using a design thinking to identify prioritize AI projects. We put at the right business objective. Implementation of any AI project has to be clearly identified and defined. That gives you a better ROI. And obviously putting the right metrics in place gives you a quantifiable value, net revenue increase or new revenue, which will help you kind of define and move ahead from there. So since we are talking about the AI infrastructure, data and cloud, We need to always make sure that the AI is not going to be active or successful without the IA, which is the information architecture. The information architecture is the key for any of these AI projects to run. So if you look at the final goal of modernizing your, making sure you are ready for a data for a hybrid and cloud world, you have to follow the steps on the ladder, we call it, in the left side. It's like you have to collect the data, just make data simple and accessible. You have to organize the data. You have to make sure its business ready analytics foundation is there. You have to analyze the data, build and scale AI with trust and transparency. You have to infuse, basically operationalize the data throughout the business, start making use of it, look at the analytics, look at the report, look at the data, look at the final outcomes. This is very critical for your data ladder to the cloud to make it work for enterprise AI projects to be successful. Now, this is the one I'm showing right now. Is a very common fundamental structure we are following. I'm picking up on one example of deep learning. Now, there's a lot of talk about data, big data, AI, and all the different models being built. It could be an XGBoost, or it could be a principal component analysis. We had done CNN and neural networks, a bunch of different modeling schemes apply to that. But picking up this one, the core foundation, or I would say the core pipeline, which is up to the cloud, this kind of remains the same. We have an edge where all the data sources are ingested. Now, data sources can be external, it could be internal, your data warehouses, which already data is there. You have external providers providing your data for this functionality. You have data being collected as like a storage tank in your company, right? You are ingesting data at the edge, which is now this, when you say edge, now data, this can be also data can be put up in the cloud, which is we are doing actually in the cloud. And there are companies who still have not in the cloud, they can put in their own data storage. And then you kind of move the data into the cloud, which is the core. Now the core is nowadays mostly becoming cloud. You can have your own infrastructure, your own servers, your own on-prem hardware sitting there. But what we are doing is moving the data which is ingested into data web zone, which is the data lake, typically we call it, and then moving from there to a training cluster where the data sets are trained. You use and reference the test sets, and then you deploy them and develop the models, and you deploy them. And then you have a repo of the different models, and you kind of look at the outcome. And there's obviously a feedback loop that is happening from the deployment to data prep zone all the time to give you a better outcome, better models. You can have data can be reused, right? You have a self-training, you have other things going on for that. And then obviously data can be stored. The stored can be in archive, you can do a private or public. It's a typical cloud model, which we think about in this current world. It's a more uh, widely used in many organizations, even including us, we are using that. So if you look at the data characteristics, we have data at the edge, core, and cloud. Edge is normally ingest, which is a normal compute heavy, write heavy, sequential, and small to large file. In the core, you have more transformation that is happening, which is more, when you transform the data, you have different sources. You take up the data, you transform it, and explore is where it's more compute intensive, and train is also compute intensive. I remember where we were like running our models. Sometimes it took like 10 hours, 12 hours. It's obviously was running on laptops from our developers. Then we kind of move into cloud. We put the horsepower to it, put the GPUs, put the more processing power to it, kind of slowed down. It really made it very fast. It was going without having our own devices being tied up. It was giving pretty good results out of that. And then you do an inference out of it. And the inference is compute intensive, read heavy, multi-tenant, and then you kind of store in the cloud, which is archive backup. You have a low compute, write heavy, sequential, and small to large files. So if I look at a use case for GSK, to give you a very good example of when I mentioned about this cloud pipe infrastructure and pipeline, I'm looking at two different scenarios here. Machine learning with looking at for digital innovation and wellness. I'm picking up a seasonal model, predictive model. And then there's a wellness and self-care. On AI cognitive services, we are using shoppers behavioral science and voice chatbots. I'll pick one or two use cases based on time we have today. And then, so looking at example of seasonal prediction, right? We have seasonal products like allergies and cold and flu products. We want to find out imagine a world where it could predict the seasonal illness and message to you as a consumers or vulnerable people to get prepared with the flu or allergy. Obviously, the COVID situation was pretty dramatic. Nobody expected that. All the seasonal models were failing for us because we didn't expect this to happen. We are working out to refine ourselves for that. And then obviously we work with our retailers to make sure we have information to the retailers about this OTC medicines that is available. Our primary objective was to inform our consumers, improve our regional and media national delivery, our become a category leader in this space, and then obviously inform our supply chain and functional team about what's going on so they can plan accordingly and ahead. The key factors here, we are looking at some couple of independent variables, external factors. We are looking at category consumption volume as a dependent variable, and obviously how it can be indicated by a major regional markets levels. Uh, if you look at how we build it using machine learning, we had 64 markers to take care of it. We were looking at Mars feature selections, then looking at different models coming out of that, and then we have to use an iterative machine learning modeling technology to come out with the best models, help us out with that. The typical plan was, I mentioned before, we had a data gathering, preparation, review. We had exploratory data analysis, forecasting model being built. We had validation, implementation, and final output of that. This is where I think is going to be interesting to you guys is from how we did that. This is our architecture. We were using Azure Databricks in our side. The left side is all the data sets. We have multiple sources. I have removed the actual sources to kind of make it as per company policy. We ingest the data in Azure Data Factory. We use a data lake, which is all data is stored. Then we use the entire prep train scenario with Azure Databricks. We are using this cycle to train, test, and predict the data. And then we use our data warehouse to store the output models, and then use analytics services to do a Power BI reports of the different models we want to have it. If you look at the way the pipeline was built, this is our basic fundamental data engineering part. We took all the sources from all the sources, if you see here, source 1 to 4. And then we have our data warehouses, which is all other data sets, historical data sets were there. The sources, what I mentioned, was coming every week as a refresh set of data. We want to make our as lively as possible data sets we have. And then we have some reference data sets. We build this entire data engineering pipeline is based on these 3 different stages. When the data is ingested into a raw data file, then we use data engineering principles, feature sets to kind of extract it and then put into a staging area. Then more transformation happens. It goes into a process data set, and then you kind of go into a final output analysis. And then depending on what category we are using it, what business project we are taking care of, that will give you an individual models, analysis, and outputs. So this is the framework of pipeline we kind of try to model and keep ourselves as a foundational data pipeline. And all of this, what you're showing is the data set is actually an Azure Data Lake, and that is primarily used to power new models or do analysis and outcomes to it. So if you look at other key factor for any of our infrastructure pipeline is definitely how do you really productionize the machine learning data sets from here, from deployment to drift detection. So this is where we have started using MLflow, which is pretty open source and being useful. So your modeling pipelines has to be built right. That the one I showed before was used to build the modeling pipelines. You do a raw data join, you do a pre-processing feature engineering. It's part of our machine learning project. You do a clean and structured, you do the modeling techniques, which you're going to use, CNN, XGBoost, deep learning, anything you want to use. You tune your models, look at the parameters, and you do evaluation and model selection. And then you have a model deployment and scoring. You kind of score the models, how they're working. What is the predicted quality? We use data lake for that, and then you have a downstream applications for that. Then you are using the model drift selection to make sure your summary are there, is a KPI there, there's a notification action, you do a predicted versus actual. This gives you a pretty better ways of making sure you have a good deployment strategy, you have a drift detection, your models are very properly analyzed and done and can be scaled up in terms of your productionizing the AI model. Now, what is the success criteria for it? We're making sure we are using a MAPE scoring, mean average percentage error scoring. We have defined a range that has to be in this range. So your success criteria is that the predictions all these models are coming out are actually within an acceptable MAPE score. We are bad if the predictions are very high. And obviously ugly is that something is very weird prediction is happening. Now, at time of winter, we are saying it's going to be a summer, which is and the allergy season is starting, which is not here there. We're just starting into winter. It's more of a cold and flu season, right? So it's maybe somewhere in Australia, which is a different pattern there, right? So those are the key parameters you keep on try to use and monitor. So that's part of any of your machine learning and data pipeline and characteristics, KPIs, whatever you call it, is part of your entire functionality. You try to look at it and go about it. Now, one additional one I was mentioning is chatbots, cognitive services, part of our AI infrastructure you are building in. We are looking at that as we go along. We have deployed a couple of them. Recently, we launched voltandgel.com. There are chatbots there. We are having voice search there. It was an arthritis-friendly website. We want to make sure people who are having suffering from arthritis are not uh, don't have to type in. We put that in, and this is a general statistics of how many voice searches are happening or searches are happening by voice. We have a 56.3 million smart speakers in the world, and we have 80 plus extra skills. We are 42% Americans are calling the smart speakers. We have 1 billion searches happening per year. So we have a big use case for chatbots happening, and there a lot of that is currently being valued there. So just give you a use case which we have done. I did not bring up the Volta and Gel use case, but this is something we had tried out with an shelf on a Walmart in the Facebook. When you can go to a Walmart shelves, you can go to your chatbots, you can go to your Facebook Messenger, you can try to find out more information using a chatbot. Now, does your cold or teeth hurt? Or if you bleed when you brush or floss, you can which product will be really valuable for you. So kind of an assistant to you while you are shopping for products in a category. At the same time, we are using now voltandgel.com. If you go to the site, voltandgel.com, we have chatbots, we have voice search. If somebody was going to type it, I want to find out more about the Volta and Gel. That's how we were doing it. Now, one key thing here is, this is again, the reason I want to bring up this information here is, we had to bring in a lot of data here for people to understand it. How you spell Volta and Gel may be different for people with different accent. So we had to start collecting a lot of data. We have to collect a lot of speech. So we did smartly, we didn't stop going outside. We took like 40 people on a company organization. We started asking them to speak about the word Volta and Gel. So because people can speak and do a different accent on Volta and Gel. Somebody can say Volta and Gel, somebody can say Volta and Gel. So there are different ways to kind of pick it up. So we kind of create, and those audio files, we collect it, we evaluate it, and then we kind of map it to the same word is going to be Volta and Gel. Then we kind of train the model. We test and train the same model, and then we deploy those custom models into custom speech arenas, and then we integrate that with the APIs, and those APIs are then being called from our website. So it's a very intuitive, and we found it very successful, kind of trying to identify and the different speech patterns for that. Again, the data is very critical here. The data were all again stored, picked up and measured, and then trained based on that data set. That is a kind of factor we had used. The problem statement was able to find out the key brands, custom speech and voice samples to train our speech. Obviously, success criteria were better engagement scores, high, bad assistance where don't understand, ask, and ugly terms was considered as gums. So those are the key criteria. We always try to look into that. We also have a shopper science lab where we kind of look at mobile eye tracking for people. So we look at gazing your eye plot, where your eyes are, areas of interest are. So we kind of take the measurement from there. Look at a quick video where you can use the headgear. We look at our panels and see where people are really looking at it. It can help us in determining the right area of interest. How are they laid in the shelf, and what topics they're looking at it. And this data set has been collected and analyzed, and heat maps are looked at it. So we can then better place our products. We can look at how we can better improve our labels or them in the current market. Again, I want to go back to the key principles. Obviously, one more topic here is our AI, ethical AI. We want to make sure everybody understands that the bias has to be removed. We are looking for tooling for interoperable AI and ethics, and then making sure that we have IP protection for AI models and laws to make sure it's forbidden to do so. And with that, I think I'm out of time, Patrika, right?
Yes, but we're giving you a big virtual round of applause for that awesome presentation. Thank you so much, and we really appreciate you sharing your insights with us.
Thanks a lot.
Awesome. So if you're looking for your next session, go ahead and check out your agenda page or take some time to connect with your peers with one-on-one networking sessions. We'll see you around.